let's move right along here. We are finally ready to introduce some things that we haven't talked about yet that you're probably all here for. So this whole process here is pretty great once we know how it works, right? We're able to do and accomplish all of the goals that we set out to. We can delay functionality without blocking our main thread, and we can run functionality, delayed functionality, knowing that this long task is complete. Great. But there are problems with this approach, right? The biggest one is that most people don't know how it works, right? Most people look at something like set timeout, think that it's regular JavaScript, and write it in a way that doesn't actually work for their use case, right? We also get into this point of potentially getting into what we call callback hell, right? Let's think about what happens when this set timeout, the callback for this set timeout is print hello, and let's say inside print hello, instead of just a console log, we have another set timeout that then runs block for 1 second, right? Something like that. And maybe we have a wait of, 1,000 here or something like that, right? When we start doing this, now we have a callback inside another callback. It's where we get into these things called callback hell. So that's not great. It's not really super clear what's going on here. The biggest thing is that set timeout looks like regular JavaScript, right? That's why most people don't know how it works, because why take the time to look into the documentation for set timeout when it's pretty obvious what it's used for, and it looks like regular JavaScript. So no need to worry about specifically looking up the documentation. It's not a great track, but it's what most people do, right? Most people look at stuff and say, can I reason about this before they go and, look up the documentation for it? Fair enough, right? We want code to be self-explanatory and easy to read through, right? But it is a problem. And it's really a problem to think about, okay, I've now sent this task out to the web API, and I've just passed it this function definition, and I'm just going to hope that at some point that function definition makes its way back into JavaScript and gets invoked in JavaScript somewhere, right? But it's not explicitly clear how or when this print hello function is ever going to be used, right? So this was the way that we accomplished asynchronous activity for a long time, not just with set timeouts, but with other what I call facade functions, right? Or what Codesmith calls facade functions, like set timeout, these things that actually send tasks off to the web API. There were other functions like that that would send out requests to Twitter, for example, and do similar things. We'd pass it a callback function and hope that at some point after we got that tweet from Twitter, that function would run, right? But the creators of JavaScript, when they were writing the ES6 spec, were like, okay, this is something we're doing more and more often. We're taking more and more advantage of this asynchronous functionality. Let's build some syntax in JavaScript and some mechanisms in JavaScript that are going to help us with this problem. So now we have something called promises. Promises are awesome. Before I introduce more about promises and the mechanisms within them, let's just start going through and just start diagramming through this code, because it's a lot more clear when we start diagramming it, the benefits that we get out of these promises, right? But quick thing, right? Basically, promises are just two-pronged facade functions, right? They both send tasks out to the web API. We're still using the web API here. We're still passing off this delayed functionality somewhere outside of JavaScript. However, we get a bonus. Inside JavaScript, we get immediately returned to us an object, a placeholder object, or a promise object, right? Is known as a promise object, right? That gets immediately returned in JavaScript, which is basically a promise of data to come later, right? It's a placeholder for whatever that delayed functionality returns, or whatever that long task returns, right? So let's take a look. This is the code that we're going to run. I'm just going to run it through it here real quick because it's a little small on the screen down here. We have this function definition display. we have this variable declaration where we're invoking this fetch function. Then we have this very interesting line here, which is future data.then display. We're gonna spend a little bit of time talking about what this line here does. And then we have our handy dandy console log of me first, right? So let's run through this line by line like we do. So Z, your mic works. Tell me what happens. First line of JavaScript here.
So we have the function display that's going to be added to the execution context.
Absolutely, display. Not to the execution context though, to the global memory, right?
Oh yeah.
Just that function definition. What are we gonna do on our next line?
And then we have a constant fetch data. So I can't really see.
Yeah. So here, let me just scroll up here.
Future data.
Yep. So we have a const future data, and future data is going to be set to what?
A fetch function, and then that takes a URL.
Yeah. And so since we're invoking a function here, right, in our global memory, that variable is just going to be undefined for right now, right? We need to actually fetch and invoke this fetch function with this URL that's here, right? And so, quick thing, right? While this might look like a regular old JavaScript function here, again, this is one of those facade functions. So not only is it going to send some data out to the web API, right? And just for the record, this is sending out to the web API, but we're not using timer here. Instead, we're using something called XHR or XML HTTP request to be able to send a packet of information out to a server somewhere and get some, hopefully get some data back from it. So we're still passing this task off to the web API using specifically the XHR feature, but in JavaScript now, we also get something in return. I'm not going to use pink. That seems silly. Let's use blue. Okay, we get something back in JavaScript here. This is one of those two-pronged facade functions. So not only do we get that, not only do we send that task off to the web API, but now we get this object back. It's a promise object. So immediately returned to us after invoking this fetch function, we get an object back. So instead of future data being undefined for a long time until we get some data back or something like that, right? We now have future data is an object. And I'm actually going to make this even bigger so that we can see it and add some properties to it along the way. So this is the object that gets immediately returned. It's called a promise object, and it has a ton of properties on it that are baked into this promise object. We're going to talk about a few of them tonight. There are many, many others that you can research at your leisure. The few that we're going to talk about tonight are status. So the status defaults to pending, right? This is a pending promise. We don't actually have any returned value yet. It hasn't been fulfilled or rejected. It is pending some data coming back, right? Then we have a value, and here is where we keep that undefined, right? So the value of this promise is currently undefined because the status of it is pending. We expect that when the status changes, we will probably have some value that gets added here, updated here. Cool. For now, that's all we're going to care about. We're going to add more pieces onto this as we keep diagramming through this, but for now, these are the things that we care about. So we immediately get back in JavaScript this promise object, and our thread moves right along. Let's say here, still at 1 millisecond. We'll go out to the web API now and talk about what happens out here, because it's slightly different from what happens with the timer, but not too different, right? So now out here with XHR, we are still checking if this is complete. And we're still going to do something when it is complete. Now, what we're going to do when it's complete is a little bit different. So XHR works like this. XHR sends out a little package, right? A request out to, in this case, we passed it a Twitter URL. So it's going to package up that request, send that request out to Twitter, and then it's going to wait, right? It's going to wait for something to come back from Twitter, but that might take some amount of time. So at 1 millisecond when we come out here, this is not yet complete, right? Nope, we still don't have data back from Twitter. What we're going to do on complete, we'll talk about in a second. But for now, out here in web browser API land, we are sitting here waiting for Twitter to come back with some result. All right then, tell me, Bren, what are we going to do on our next line? What's the next line that we're going to hit in JavaScript after we hit this const future data?
We are going to go to the next line, which is future data.then, which is a function we invoked from the future data object.
Yeah, and what are we going to pass it?
We are going to pass it display, which is the function definition we stored in global memory.
Absolutely, thank you so much, Bren. We're going to pass it this function definition for display. So let's talk here, right? We are invoking a method called then, right? We expect then that whatever future data is, which we said, right, is an object, has a property on it with a name, with a value, or a property with the key then, and a value of a function definition. Surprise, surprise, that is very true, right? Part of this promise object, another property on this promise object that's baked into it, that we get immediately returned to us, is a method called then. This then method does a few different things, but what its main purpose is to attach delayed functionality to this long task. So right here, we're seeing another additional benefit of this promise object, right? Not only do we have a way in JavaScript of seeing sort of the status of our promise, the status of our asynchronous activity, but now we have a way of decoupling the asynchronous task from what we want to do after it's done. So we have a way of saying, okay, we want to get tweets. We can write this function to get tweets, but we can separate it from what we want to do after we've gotten those tweets, or what we want to do if getting those tweets fails, right? And we can do that by using this then method that's available to us on this promise object. I'm going to delete the then out of here. It's not gone anywhere. I just want to use this board space for something else, because what this then method does is it takes this function definition that we pass it as the first argument. It wraps that function definition with some specialness, right? Some special permissified functionality, and it basically adds that definition, that function definition, to an on fulfillment property that also exists on this promise object. This is getting a little small here. I apologize for that. So on fulfillment is another property on this promise object that we care about. Its value starts out as an empty array. What we push into this on fulfillment array are function definitions that have been specially wrapped by this then method. And it's basically saying, this is what we want to run as delayed functionality if this promise is successfully resolved. In this case, that promise is getting tweets. So if we successfully get those tweets, we want to then run, why does this keep moving? We then want to run this function definition that we've passed in here, which is for display. Quick thumbs on that. How do we feel about this? Sweet. All right. So then, we have finished running this then method. Our thread is ready to move on. let's say 2 milliseconds. We're ready to move on again. What are we going to do next? Alex, are you there? No, Alex, I'll come back to you. Let's see. Peter, what are we gonna do next? Oh, you're muted.
Oops. Sorry.
No worries. Happens.
We're gonna create. Yeah, it happens often. We're going to create a. We're going to go down to the console.log line. And we're going to create a. We're going to create a new local execution context and push that function onto the call stack.
Absolutely, and I've just realized I've made a grave error in that global was not on here. That's okay, it's on there now. It's been on there, let's pretend it's been on there the whole time. So yes, we push console log onto the call stack, right? Woo, great. We get a new function level execution context. I'm gonna make it much smaller than that because we're gonna be hurting for board space here in a second. Sweet, console log is going to run. Over here in our console at around 2 milliseconds, we should see me first, right? Cool. What happens when we're done running this function then, Peter?
The local execution context is going to be erased. You're going to deallocate that memory, and then console.log is going to get popped off of the call stack.
Beautiful, absolutely. Thank you, Peter. Sweet.
No problem.
So at around 3 milliseconds here, then we're back out here. Console.log, all done. Great. Do we have anything else to run in our global execution context anymore? Spoiler, no, right? We've already done this last line here. We have nothing else in our global execution context. We're still maybe waiting out here in web browser API land. It probably takes a little more than 3 milliseconds to get something back from Twitter. But at some point, let's say that some point is around 350 milliseconds, we get finally our tweet back from Twitter, which is our beautiful hi, beautiful string hi, right? Great. So at around 350 milliseconds, when we get this string back from Twitter, our function is complete. Now, this is a little bit different, right? Did we, Joseph, did we pass any callback function to the web browser API?
No.
No, right? All we passed it was this URL, right? The URL that we wanted to send the request to. So in this case, the web browser API doesn't necessarily know what delayed functionality we want to do, but it does know something that fetch sends out to the web API, right? Is that this is a promisified function. This is a function that has a promise in JavaScript, and so all that the web browser does on complete of this particular deferred or this particular long task is it's going to update the status and value on this promise object. It's going to take whatever value is passed back from Twitter in this case, and it's going to put that as the value for the promise object. And it's going to update the status of that promise object in this case, because we successfully got back a value from Twitter, right? To fulfilled or resolved. Resolved, I think, is actually what it goes there. Successfully resolved, right? So now over here, our status is resolved. Our value is high. And now we're ready to trigger this delayed functionality, because in JavaScript, we do know what delayed functionality we actually want to run, right? Now, where to put this delayed functionality, you might be wondering. Or you might not be wondering. You might be assuming that we just put this delayed functionality right here in our callback queue because that's where delayed functionality goes. And that's a pretty fair assumption or guess, right, as to where this stuff goes. But there's one other piece of promises that we want to introduce here, which is that promises get a higher priority and get some special functionality by using a different queue. So not only is there a callback queue here, but there is also what's called a micro task queue. And the micro task queue works similarly to the callback queue in that nothing that's in the micro task queue can get pushed onto the call stack until the main synchronous JavaScript thread is clear. However, the micro task queue gets prioritized above the callback queue. So by virtue of our promisified function here, this fetch function, being a promise, our delayed functionality of display, instead of getting pushed onto the callback queue, is going to get pushed onto this micro task queue. Sweet. So it goes on to this microtask queue, and now, right, this is around, let's say, 350 milliseconds. And since our main JavaScript thread has been clear since 3 milliseconds, by the time it hits 350 milliseconds and this display function gets pushed onto the microtask queue, we are totally ready for this function to be invoked, right? So the event loop says, okay, we're ready to invoke this function, so let's get this thing off of the microtask queue. Let's push it onto the callback queue. Or sorry, not onto the callback queue, onto the call stack. Woo, it's getting late. It's getting late, y'all. Okay, so 350 milliseconds, global execution context clear. Event loop says, all right, let's drain the microtask queue, takes that display function, pushes it onto the call stack. Dennis, tell me, what happens when we invoke a function here in JavaScript?
We create a execution context, a function execution context.
Absolutely, we do, and great. And we actually have a function definition here for this one, right? So let's run this one line by line. What's the first thing we do when we start running our JavaScript code?
We got console.log data.
Ooh, before that. So before we start running that code line by line, right? We need to take care of arguments.
Oh, the data,
right?
yeah.
Or parameters. So
put that in local memory.
Now, absolutely, we're going to put that in the local memory, the function level memory. What are we actually going to put there?
It's going to be starts with the U, undefined.
So it actually doesn't start with undefined, right? When we invoke a function, we have to pass it something, right? And in this case, when we invoke this function display, before we know how it gets this data, what do we expect? You know, just knowing what we've got access to here and what our code is set up to do here. What do we expect that value to be?
Whatever it got from fetch.
Yeah, so that string high, right?
High. Mm-hmm.
This is what comes back. So we expect that the string high is getting passed to this display function.
Got it.
Right? So that's totally right. I thank you for you know, playing along with me there. That was a particular you know, I was hoping that you wouldn't know the answer to that one. So yeah, just before you keep going there, I just want to quickly explain how we can assume that that's what will get passed there. It's not really an assumption. It is something built into the spec of promises. So the way that promises work and the way that promise deferred functionality gets invoked is that promise deferred functionality, things that are in this on fulfillment array or for error handling in an on rejection array, will automatically be passed when they're invoked. It will automatically be passed whatever the current value for that promise is. right? Whatever promise object they were attached to, that functionality was attached to, will automatically be passed the value of that promise object when it's invoked. So when the event loop invokes this display function, it's automatically going to be passed the value of that promise object at that time, which was high. So excellent, Dennis. As we're going through, we're setting data now to the string high, right? So now what are we going to do? What's the next thing we're going to do when we're running this display function?
We console.log, and that creates a new execution context. And we push that to call stack.
Absolutely. We get a new little function execution context here. Right, it runs, console log is on our call stack here. At around 351 milliseconds, we're going to see, hi. Sweet. And then, right, of course, both of these get
Pop
popped
everything.
off. Boop, 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 boop. Boop. Gone. Sweet. And we have nothing left in our main JavaScript thread. We've got nothing left in our queues. So now we're all done. Right? Quick thumbs on this. How do we feel about this promise deferred functionality? Sweet. Just as a, kind of quick recap here, right? Promises are literally just these special objects that are built into JavaScript. They're immediately returned to us when we invoke permissified functions, right? When we invoke any function that's been built with this promise object inside, we immediately get back this promise object. That promise object comes with a bunch of built-in features. Some of those core features that we care about are that we now have in JavaScript a way of tracking the status of that promise, knowing that it's pending, that it's still out there in web API land waiting to be resolved. We can tell when it's been resolved because that status gets updated. The value gets updated with whatever that promise resolves to, right? And then we can attach delayed functionality to that promise object specifically. We can attach that in JavaScript so that we can keep track of what delayed functionality is going to be run, and we can sort of decouple the asynchronous activity from what we want to do after we've done that asynchronous task. So we could have potentially permissified functions that we reuse in different places, the same function that we reuse in different places, and we just attach different delayed functionality to it instead of having to rewrite that permissified function over and over and over again for different use cases, right? With callbacks, we always have to pass into that callback function what we want to delay. So we have a harder time doing things like reusing those functions in other places, right? Also, something we didn't look at here specifically in this example, but something that comes in handy a lot with promises is that not only can we attach using the then method delayed functionality for when that promise successfully resolves, but we can also attach different functionality to go down a different track if that promise rejects or fails to resolve, right? So we have this awesome way of being able to do more specific error handling as well, which is great. So one last example that I want to walk through, which is bringing all of this stuff together. Because I want to note, right, that this is not something that is, it is the kind of the new standard, right? So new things that are being written are often using this promise syntax, right? Using these features. However, set timeout is still a set timeout. Set timeout still under the hood is using, or not even under the hood, set timeout is still using callbacks. You can wrap existing callback functionality in promises. You can add a little bit of extra logic to your set timeouts. You can wrap those functions in promises. That's for a later time, a later topic. But under the hood, right, they're still using callbacks. So let's take a look at sort of priority order and how this stuff kind of all comes together in a really specific example that brings in all of the things that we've talked about tonight. So we're going to have synchronous code that takes a long time. We're going to have callback functionality that's asynchronous. We're going to have permissified functionality that's asynchronous. So let's see in a final example of how this stuff all comes together. Before we dive into that, let's do some quick questions. There's a couple of things in here. Cool. Where does the value high get passed into the variable called data? I think that's been answered, but if you still have that question, let me know. Jeremy, so the event loop, callback queue, and microtask queue always exist, or do they only start when JavaScript sends something to the browser API? They always exist, right? Those queues always exist. We just don't really ever use them or we don't really ever see them being used, with the exception of these things. They get used potentially for other things under the hood that we never really even talk about in JavaScript, or that we never really actively use. These are the times that we as JavaScript engineers care about them existing, but they do always exist. Was it the usage of the .then that passed what got resolved from the XHR high that passes the argument for display? Yes, okay, it's been answered. Sweet. Yes, absolutely though, Tyler, that is what happens. Because we used that then method to attach display to that promise object, right? That special magic that then method works. Part of that special magic is to make sure that the value that gets passed to the function we're invoking is the current value of the promise object. It's basically wrapping that functionality that we pass into it, that display functionality that we pass into it, wrapping that with some additional logic to make sure that it gets the data that it needs when it's invoked.
Quick
I have a
question.
quick question. Oops, sorry, go ahead.
Dennis and Tyler, or Dennis and Peter.
Okay, so do you have to know the type of data that you're going to be getting back beforehand?
Yeah, it's probably good to know what data you're going to get back in the format of that data, so that whatever delayed functionality you're using is using that data in the right way.
Okay.
This is just a curiosity question, but if you had a function in the onFulfillment that, as part of the onFulfillment property of that promise object, that also had a hard-coded argument, how would that work? So like if you had two arguments, one of those being data, one of those being a hard-coded argument, is that something you can do, or is that something you wouldn't?
What do you mean by a hard-coded argument?
Like something you actually pass into the function, like a number or something like that.
So you'd probably need some sort of like wrapper functionality to be able to do that. If your promise object isn't going to provide that, it's probably not a delayed function that you'd want to be using in that particular case, right? You may need to do something like have an anonymous function that wraps your display function then and passes not only the data that comes in from the promise object, but then whatever other data you'd need for that function to run.
Gotcha.
I had a question.
Yeah.
If you invoked, the fetch call, the fetch API call, not in global, but you called it in some other, execution context, would that promise object be stored in the local memory, or would that promise object be stored in global?
Great question. It does get stored in that kind of local memory, but that's where we get into some questions that are maybe a little bit outside the scope of the talk, where we're still able to run that delayed functionality. We still have reference to that object in memory outside of the context that it's scoped to in JavaScript. So we only have access in JavaScript to it in that function level memory. But remember that function level memory being scoped is scoped in JavaScript, but it's still just living in a memory space allocated somewhere on a machine. So it still exists outside of just that context. Little outside the scope of what we're talking about, but is a good question. Yes, it's still scoped in JavaScript to the context in which we define it, but is technically still available outside of that scope, outside of JavaScript.
Got it. Thank you.
Yeah. Evgeny, do you have a question?
Yeah, I haven't really. I worked with Axios or whatever, however you pronounce it, and then I've seen like a little bit of async and wait stuff. Is that like syntactic sugar for promises, or it's got like its own thing going on?
Yep, absolutely. I'm going to touch a little bit on async await at the very end. and tell you why we don't talk about it a little bit more in this particular lecture. But great question. I'm gonna get there. Sweet. All right, let's do this final example, and then we'll round out with some final questions at the end. Alrighty. So this is what we're gonna go through. If you thought the last one was hard to read, let's take a look at this one. So let's take a look at this one beforehand. First things first, we are just going to be, we're just going to be looking at defining some functions in the beginning, right? We're still gonna have our display, we're still gonna have our print hello. Now we're bringing back that block for 300 milliseconds this time instead of 1 second because, woo, we wanna be a little different. We're still getting a set timeout this time. We're combining that with a permissified function, that fetch. We're doing that synchronous blocking of blocking for 300 milliseconds. And we're console logging me first. Which will run first? We can only hope that it's still be first. All right, here's all the things. Everything is set up. I promise we're not introducing anything new, any new pieces of the diagramming. We're just gonna make sure that we're all on the same page about how this is working. So, kick us off, Bren. What's happening? First line here.
It's really hard to see. But
yeah, here, I'll just throw
okay.
you up here real quick.
Thanks. Yeah, so we're declaring a function called display in global memory with a function definition.
Next line.
Then we are declaring a function definition labeled print hello.
Next line.
Another function definition labeled block for 300 ms.
Sweet. Next line.
We are calling set timeout or invoking set timeout, and that's an API call. We will not be calling that with synchronous JavaScript. So
amazing. Yes, we hit this. Whoops. We hit this set timeout. What arguments are we going to pass to this set timeout?
We are passing it the function definition labeled print hello in our global memory, and then the number 0.
And the number 0. And you are exactly correct. We are not going to run this like synchronous JavaScript, but instead we are going to do what?
We will be calling the web API.
And do you remember what specific feature of the web API we're going to call?
Timer.
Yeah, timer, right? So we're going to use the timer feature out here in the web API to handle doing this long task of setting a timeout. But that's all we're going to do in JavaScript, right? We're going to pass it out there. Once it's done, once we're done passing it out there, we're going to move on right along in JavaScript. And what's the next line that we're going to hit in JavaScript, Joseph?
Sorry, I can't really see.
Oh, no worries.
Yeah.
Sorry, here we go. We just ran set timeout. We passed that off to the web API. Whoa. We passed that off to the web API. What are we going to do next?
Okay, so we're declaring a constant feature data. And we're setting it to fetch with the link to the Twitter.
Yeah, so just to be clear, right? We're not setting it to the fetch, right? We're gonna in global memory, right? We're gonna define this constant with the label future data. Its value is eventually going to be something, but for now, right, we need to invoke whatever fetch is. So for now, it's going to be undefined, right? Before I have you move on though, Joseph, right, we're going to pause here. This is the line that JavaScript moves to, but let's quickly round out the web API here. We had passed something out to the web API, and I want to make sure that we document that. So the web browser API, right, is going to check if something is complete, and then once it's complete, it's going to do something, right? On completion, we're going to do something. First thing that we have out here, right, is our timer, and that's going to be taking in a function definition, in this case, print hello, and a wait of 0 milliseconds. So out here at 1 millisecond, when this timer starts, Bren, you were running me through this. When we're out here on the web API at 1 millisecond and this function comes out here, are we done running the timer?
Yes, we are.
Yeah. So what do we do on completion of this set timeout?
We push the function definition print hello to the callback queue.
Yeah, absolutely, right? What we want to do on complete is say that this print hello function is ready to be invoked. So we take that and we push it onto the callback queue here, right? This function print hello comes on here at roughly 1 millisecond, sitting out here, hanging out in the callback queue. Amazing. Now, back to JavaScript land. And Joseph, you were running me through the future data constant here. So tell me, what are the two things that happen when I invoke this fetch?
It creates a promise object.
Absolutely. We immediately get returned to us a promise object. We'll talk a little bit more about that in a second. What's the second thing that it does?
And it pushes onto the web API.
Yeah, it sends this task out to the web API. Do you remember what feature of the web API we use for this one?
XHR.
Yep, XHR. Do you remember what it stands for?
It is called HTTP request.
Yep, XML HTTP request.
I
Yeah,
got it,
close,
yeah.
close enough. That was just bonus points. It's
Got
just,
it.
I would like to see who can remember it. Excuse me. Yep, so we pass that out to the web API. We're gonna specifically in this case use the XHR feature. Do you remember, Joseph, what the XHR feature, what that does?
It sends a request to the Twitter.
Yeah, sends off that request to Twitter. And so at roughly, let's say we get out here at 2 milliseconds. At 2 milliseconds, is this function complete? Have we gotten our tweets back from Twitter yet?
I don't think you know yet. Is that correct?
No, right? Yep. So it's not complete yet at 2 milliseconds. We're still waiting. Right? This request has just been sent off to Twitter. We haven't gotten anything back yet. So at 2 milliseconds, we're still kind of hanging out here in web browser API land, just waiting for those tweets to come back. Meanwhile, back here in JavaScript land, let's dig in a little bit more into this promise object. So you're totally right. We get immediately returned to us in JavaScript this delightful promise object. I'm gonna reallocate my board space here a little bit more. Let's move this down. And let's say that we want to have future data be this whole big promise object here. And then let's put console back down here. Good. Okay, so future data is very briefly, before we actually fully invoke this fetch function, it's very briefly undefined. As soon as we invoke this fetch function, we get immediately returned to us in JavaScript land this promise object, right? Tell me, Joseph, two of the things that we care about on this promise object.
The status and value.
Yeah, and what does the status default to?
Pending.
Pending, absolutely. What does the value default to?
Undefined.
Absolutely, undefined. Amazing. Thank you so much, Joseph. All right, now, still in JavaScript land, we move on to whatever the next thing is at around 2 milliseconds. Tell me, Kate, what's the next thing we move on to?
Can you move slide down a little bit, please? Can't see.
Oh, yeah, sorry. No,
so
no worries. So we just did this line here.
We hit the next line, invoke block for 300 milliseconds.
Oh, sorry. So to be clear, we just finished this line.
Oh,
we're now
I'm
here
sorry.
on this line.
And then we invoke the method display in the object future data.
So very close. We invoke the then method, and we pass it the function definition for display. Right? So we're
Yes.
invoking this then method, and we're passing it the whole function definition for display. Great. And so tell me, Kate, what do we actually do with this function definition here that we pass into the then method? Where does that go?
And then it's got attached to the property called onFulfillment or onFulfill in future data, like the promise object.
Absolutely. It gets pushed into this array on the onFulfillment property on that promise object, and we just push in that display function definition, right? It's now been wrapped with some other functionality by that then method, right? But essentially what we're doing is we're taking that display function definition, that specially wrapped display function definition, and pushing it into that onFulfillment array. Awesome. Thank you so much, Kate. Next, what are we gonna do? Tyler, you still there?
Yeah, I'm here, but my mic didn't work the last time.
Ah, no worries. Your mic works now. So, Tyler, tell me, what are we gonna do on our next line then around 3 milliseconds?
We're looking at a function that's called block for 300 milliseconds. No argument.
Yeah. And what happens when we get to this line? What are all the steps that we're gonna do here at this line?
A new execution context gets created.
Absolutely, it does. What happens to our call stack? Oops.
And we get to add block for 300 milliseconds just above global on our call stack.
Yeah, we get to push block for 300 milliseconds onto our call stack there. And then what happens in block for 300 milliseconds? Do we know?
We block for 300 milliseconds.
Yeah, exactly, right? We block for 300 milliseconds somehow, right? One way that we talked about
as a
before.
comment right now.
Yeah, right. Tyler, do you remember what one way we could block for 300 milliseconds? What's something we could do?
We could run a loop for a little while.
Yeah,
With a
we could
big
run a long loop.
Yeah.
Yeah, exactly. Right. So we block for 300 milliseconds. So we're gonna add 300 milliseconds in here somehow, probably with some sort of loop. Awesome. Thank you, Tyler. We're gonna pause in there for a minute while that block for 300 milliseconds is running, and we're gonna revisit our web API out here. So let's say while that block for 300 milliseconds is running, Twitter comes back at roughly, let's move this around a little bit so we have enough board space, right? At 2 milliseconds, this XHR was not complete, but let's say around 250 milliseconds, now we've gotten our tweets back from Twitter, in this case, our singular tweet back from Twitter. And so, Joseph, right, you were running me through the XHR part of this. What do we want to do when this XHR is complete?
It updates the status and value for the promise object.
Yeah, goes into memory, updates that status to resolved, right? And that value, what are we gonna update that value with?
With high.
With high, right? String high. So sweet. Up here, status becomes resolved, value becomes high. Great. Now, because that status has updated to resolved, and we have a value now, and because it was resolved and not rejected, right? It didn't fail. We're ready to, invoke the functions in this onFulfillment array, but we can't quite do that yet, right, Joseph? So what do we do with the functions in this onFulfillment array?
You push it into microtask queue.
Absolutely we do, right? So we take this function definition here and we put it onto the microtask queue over here. It's going to be that display function definition, and that comes in here around, let's say, 250 milliseconds, right? Awesome. Thank you, Joseph. So let's run back here into JavaScript land. Let's say that now block for 300 milliseconds is finally done. So out here we come around 303 milliseconds. Tell me, Tyler, what happens when we're done running this block for 300 milliseconds function?
Then we're looking at our next line in JavaScript
Oh,
land.
before we're looking at the next line, what happens when we get done running a function? What happens to our call stack, to our local execution context?
The local execution context goes bye-bye, and also the block for 300 milliseconds gets popped off the call stack.
Absolutely. Thank you so much, Tyler. Sweet. So now 303 milliseconds back out here in our global execution context. Tell me then, Yevgeny, what happens in our global execution context? What else do we have to run out here? Oh, here you go.
So we called block for 300 milliseconds. That's finished. We popped it off the call stack, and then we delocated it, right? Well, popped and delocated, and then so I think we just go to the next line, right?
Yep. So what line are we at now?
Console.log.
Sweet. Run me through that console log.
So we're gonna create another execution context.
Yep. And what else happens to our call stack?
We're gonna push that on the call stack.
I'm just gonna make a really tiny execution context here because I'm running out of space just so fast. Console log pushed onto the call stack here, right? In our console then, first thing that we're gonna see, luckily, right? First thing we expect, around 303 milliseconds, we're gonna see that me first. Awesome. Now that that's done running, Yevgeny, what happens to this local execution context?
So once the method is done, it's gonna delocate. It's gonna get popped off the call stack.
Absolutely. Awesome. Thanks, Yevgeny. Sweet. So now around 304 milliseconds, our global thread, our global execution context, right, is done running. Woo! We have no more synchronous code to run, right? All done with that. Console log was the last line here. Now the event loop sees that that JavaScript thread is clear and says, all right, let's check those queues, right? Got some stuff in the queues. So tell me then, Dennis, what is the first queue functionality that's going to get put onto the call stack, pushed onto the call stack?
Oh, display is going to go up to the call stack.
Yeah, how come display is going to go onto the call stack? It's only been here since the 250 millisecond mark. How come it's not going to be this callback queue one?
It's got priority.
It's got priority. Yeah, it just is, right? Sweet. So absolutely, display is going to be removed from the microtask queue. It's going to be pushed onto the call stack, right? So tell me then, Dennis, right? Display gets pushed onto the call stack around 304 milliseconds, and display takes in an argument, right? What are we going to pass to display?
The value of the promise, which is going to be high.
Which is currently high, right? Awesome. Sweet. Not his. High. Awesome. We get a new function level execution context, right? What are we doing in our display of high in this function level execution context? Oh, sorry. There you go.
We're console logging high. So we're going to create another execution context within that. I'm going to push that to the call stack, and then console log high, put it in the console.
Console log.
And then we're going to pop everything off.
Yeah, absolutely, right? Around 304 milliseconds, we're going to see high in the console, and then of course back here we're going to be done running console log. We're going to pop that console log off the call stack. Then we're going to be done running display, so we're going to move we're going to pop display off the call stack, and then we're going to be back out here around 305 milliseconds, And now, what are we gonna do? Peter, what's gonna happen now here at 305 milliseconds?
We are going to push that function from the callback queue onto the call stack.
Absolutely. So off the callback queue and on to call stack, print hello. What happens here when we invoke print hello?
We're going to create a new function level execution context.
Definitely we are. Great. What happens inside print hello?
We're going to log the string hello to the console, which requires you to push the console.log or the .log method on the console to the call stack, and then open up another function level execution context within print hello.
Absolutely, it does. Thank you so much. Right. So great. We're running console log. Then over here around 305 milliseconds, we are going to see hello. And then, of course, when we're done running all of these functions, what happens, Peter?
We're going to deallocate all that memory that we allocated initially for the local execution context of console.log, and then we'll pop console.log and do the same thing for print hello.
Absolutely, that's what we're going to do. Whoa. Thank you so much, Peter. And then back out here in our global execution context around 306 milliseconds. Now what are we going to do? Yevgeny, what are we going to do next?
I was still trying to follow. So we don't have anything on the queue, on the callback queue, and the micro test queue. So if there's nothing there, that's it. We're done. We're done with the app. Yeah.
Absolutely, we're done. Yeah, that's yeah. It was that
was a trick one.
Good
huh?
call.
Thank you.
It was a little bit of a trick one, but yeah. But it's a good one to, it's, you know, a good step to do at the end of everything, right? Is, you know, we may think that we're done, but, you know, always good to make sure, right? All of our synchronous code is done. Our microtask queue is done. Our callback queue is done. So yeah, so we are good to go. We have done all the things that we needed to do, right? We've diagrammed through not only running synchronous JavaScript code, not only running asynchronous JavaScript code with callbacks, but also running asynchronous code with promises and doing it all together. And we see kind of the order in which these things happen. And so kind of in summary, right, when we talk about promises, this is super, super helpful, right? It takes on a whole new level of being able to track through our JavaScript code and our asynchronous JavaScript code inside JavaScript, right? We don't have to just rely on passing in a callback to some you know, random function, right? Or not even random, but passing off this this delayed functionality, just passing it in as a callback function and hoping that at some point it gets invoked, right? Now we have a little bit more control, a little more explicit control in JavaScript about what delayed functionality is going to run, and if it's going to be run on a successful condition or if it's going to be run on a failure condition, right? We have a little bit of a way to track through inside JavaScript the status of that asynchronous activity, the current value of that asynchronous activity. Some things we didn't get a chance to talk about tonight, or that kind of are just next steps of things to look into, are promise chaining, right? So what if we want to grab a tweet from Twitter like we're doing here with future data, and then instead of just displaying it, maybe we want to display it, but then maybe we also want to get some more details about the author of the tweet, right? We want to get the followers of that particular author, or the comments that were, or replies that were sent for that tweet, right? So we might want to have a bunch of chains of promises. So we first want to get one tweet, we want to display that tweet, then maybe we want to go and fetch all of the replies for that tweet, then maybe we want to display those replies for that tweet. All of that, if this were non-permissified, if this was just using callbacks, would have to be in one giant kind of messy code block, right? But now with promises, we can actually do promise chaining. So we can have future data dot then display dot then fetch replies dot then display replies, right? And we can see all of that in, you know, kind of right in line in JavaScript. It's very clear the order in which things are going to happen. And we can still have error handling that is either specific to each of those individual chains, or we can attach an overall error handler if at any point in this chain something fails, just catch that an error has happened and do something else, right? Break out of this chain and instead go to this error and run this error function. So we have a lot cleaner error handling with promises. But again, we still have that little bit of a problem that a lot of people don't know how this works. And Evgeny, you asked earlier about async await, which, right, if you kind of look up anything about asynchronous activity in JavaScript, anything new in asynchronous JavaScript, right, you're going to see a ton of examples, a ton of articles, and a ton of things about async await. The reason that we don't talk about it in this workshop is that it's more syntactic sugar on top of promises. You should still know, if you really want to understand async await, you need to understand how these raw promises work under the hood, right? Because it's all using this this promise functionality under the hood. There are some additional benefits, definitely a lot of syntactic benefits to using async await, but to really understand how your asynchronous code works, promises are the first stop, right? Async await is another layer on top of it that's more of a deep dive and requires you to also just know some other features of ES6, so it doesn't really work for this particular workshop, but would kind of be the next step to go once you're feeling pretty confident in promises. Awesome. Let me just make sure that I'm not missing any particular things in the slides here, and then I will move to questions. Give me 1 second. I did it again where I let my screen die, but there we go. Okay, yep, this is more just a recap slide. Again, you'll have access to these slides. Whoops. Again, you'll have access to these slides afterwards, so so you'll be able to see all this, but this is basically just a recap slide of being able to see that we have the microtask queue, we have the callback queue, kind of they have a priority order, right? And so just a recap on that. And now we can delay functions running until the work is done and the data is available, right? This is a huge driver for modern web applications. Any web application that you're using, particularly anything that's run with some sort of front-end framework like React or Angular or Vue, right? All heavily reliant on this ability to do asynchronous activity. Awesome. We don't have any pair programming tonight, but I would love to take any final questions, and then we'll go to the, I'll Slack out the fast track application code, which is something that you're probably waiting on. So let's see, I'm gonna go look back at the comments. Feel free to shout out questions if you have it in mind.
I have a quick question regarding the microtask queue. Does the hierarchy or the precedence that it gets run depend on the particular web API that's invoked? Did I miss that?
Does the precedence, sorry, can you say that one more time? The precedence or the?
Yeah, the order, the priority, I guess I'm mentioning. Does that depend on which of the web APIs get invoked? I think I missed that.
So the priority for this asynchronous functionality depends on whether or not the function that you're using, the facade function that you're using. Right.
My confusion is how does it know to go to the callback queue versus the microtask queue?
Yep. So callbacks, callback queue, promises, microtask queue. Anything that's deferred and delayed using promises, microtask queue. Anything that's not using promises, but instead is just using this kind of callback pattern, callback queue.
Easy enough. Thank you.
Yep, totally. All right, Robin said, so assuming there are a number of functions running after display, display takes 500 milliseconds to fetch data from Twitter. while the other functions are running asynchronously. So will it slot right back after it is done? I see. So I think I understand this question, but I just want to, I just have some clarifications here. So when you say there are a number of functions running after display, are you talking about synchronous functions or asynchronous functions? It looks like you mean asynchronous functions, but I'm not 100% sure. I might want to just chat with you afterwards about that particular use case, because it's honestly going to depend on the order in which this asynchronous functionality is invoked, as well as the order in which it is resolved, and how quickly other things are being pushed onto the microtask queue. So for now, the answer is it depends. And then in general, how do we find out what the data type of the value XHR will return when we call fetch with a link? Great question. Documentation, right? So in this case, we were sending a fetch out to Twitter, or the Twitter API. So the Twitter API is going to have a whole set of documentation around how it returns data and what type of data it returns. It will probably never actually be a string. Most likely it will be some sort of JSON data that you'll have to parse through, but not always. But more likely than not, that's how Twitter's going to return you data. But a great way to know how the data is going to be returned, API documentation, right? Documentation for wherever you're fetching the data from. Jeremy says, I'm curious about the mechanism by which the callback in then callback is triggered. Is it sort of like upon setting the promise object's value property, the browser API checks to see if there's an on fulfillment property and adds it to the microtask queue? If so, great question. That is a great place to start looking at the promise documentation. MDN has awesome resources on how this promise object works, the different methods that are applied to it. There's also just kind of looking at the spec for like the ES6 spec will give you a lot of those kinds of answers. It has very detailed information about kind of the order in which things happen, the way that this functionality gets pushed onto the microtask queue. For now, it's a little too heady to get into tonight, but a great place to look for that is the actual spec for promises or something like MDN. It'll give you exactly kind of line by line how it gets from the web API back into kind of JavaScript land into the microtask queue. When you call then, it pushes the function onto the on fulfillment. Absolutely, that is one of the things that the then method does, is it pushes it into this on fulfillment array. It does so kind of after wrapping whatever function definition you pass into it with some more logic. So it basically takes our display function and wraps that display function definition that we pass it with some more logic to make sure that when this promise gets resolved, that display function is actually getting invoked with the proper data, right? That it's actually getting invoked with the value of the promise object. A great thing and another great way to get more of a sense of how that mechanism works is to look into writing your own promises, because you get a sense of what's actually happening in a fetch, right? Specifically, that fetch inside of it has baked into it, creating this new promise object, invoking that fetch, and then making sure that whatever that additional functionality is gets past the value that that comes back from that fetch request, right? So taking a look at creating your own promises from scratch. When it's done, the value will be set. When it's done, the value will be set, and then whatever functions are in the on fulfillment, it will all be called with the value. Correct. Yes. And just to clarify in my mind, the microtask and callback queue both wait until all the synchronous JavaScript executes, and then is thing of priority on both, right? Yeah. So exactly. So any functionality in the microtask or callback queue is going to wait until synchronous JavaScript code runs and finishes. And then the priority is always going to be microtask queue prioritized over callback queue. Cool. MDN is the best. You're all correct. Is there a way to synchronously check if there is any asynchronous functions in the micro callback queue and then forcefully invoke them? Assuming that it would be bad software development. So I'm not going to necessarily comment on bad software development, but the answer is that you can't do that. So you can't like forcefully invoke, at least not in JavaScript. You can't forcefully invoke any of this asynchronous functionality. You can't change the priority order. The spec is the spec, and as long as the browsers have implemented the spec accordingly, this will run in this order every time. There's no way in this particular case to hijack those queues and forcefully invoke them, which is a good thing. Great, it's been so lovely meeting all of you. Have a great rest of your night, morning, whatever time it is for you. Awesome.